Have you ever wondered how planes fly in the air? It took a long time before humans could get it right, but it was worth the effort. Through the contributions of countless great minds towards the field of aerodynamics, flying planes became possible. Let's have a look on how it works.
Thanks to airfoil technology, the curve shape used for flight is optimized for lift and stability. Bernoulli's equal time law is often applied to explain lift, but it is not backed up by any actual physics. To truly understand how lift is generated, we need to know the Coanda effect. The Coanda effect is a tendency for fluid jet to attach to a convex surface due to friction, which slows the particle down. When air particles or fluid running through the streamline of a wing bounce off the surface, it generates an opposite force known as lift. The curvature of the wing is what determines the pressure differences that help generate lift, and it is also the reason why the particles travel faster on the top surface compared to the bottom surface. The less pressure, the higher the velocity, and the more pressure, the less velocity. Let's learn a bit about the functions of a propeller. A propeller creates thrust. Similar to the wing design of a plane, the propeller's blades are shaped in order to have low pressure on one side and high pressure on the other. The angle of attack is the angle between the relative wind and the chord line. In other words, it is the angle at which the plane is actually ascending. With the use of an engine, the propellers are able to spin. The number of blades varies depending on the power of the engine. If the engine is stronger, the plane requires more blades to evenly distribute the force. Now that we've found out about the functions of a propeller, it's time to talk about how the airplane moves. In order to maneuver a plane, the yaw, the pitch, and the roll are altered, usually simultaneously. You can alter those three components by changing the flow of air pressure at different parts of the plane using the maneuvering components, which are the rudders, the ailerons, and the elevator. The ailerons control the roll by shifting high pressure on one side of the plane and low pressure on the other. The elevators control the pitch, which will change the direction downward or upward, and the rudders control the yaw, which will change the direction of the plane to one side or the other. So, what are the limitations of aerodynamics? How can we increase velocity? What material is the most aerodynamic? How big can planes get? These are all barriers that can be surpassed thanks to the advancements of technology and the great minds working towards the field of science. You can bring about the future of science. It all lies in your commitment.